Hello and welcome back to Basic. I am Miss Bali, your teacher for chemistry. In this next segment, I'll be talking about mass, molar mass, and the number of moles and how they are all interconnected. Recall that molar mass is the mass of 1 mole of a pure substance, and the units that we use to express the molar mass are grams per mole. Now, we're going to take a look at an example here with methane, CH4. And in order to calculate for your molar mass, you do need to consult your periodic table. Remember that you can use a regular periodic table of elements. You may have one printed already, or you can go online to ptable.com. So we are going to the internet right now, and we are going to access ptable.com. So here we are at ptable, and we are going to look up the atomic mass of carbon and hydrogen. So as you can see here, carbon's atomic mass, if you remember back from the first unit, is the number at the bottom, 12.01. We just need 2 decimal places. And for hydrogen here, element number 1, we have 1.008. We can just round up to 1.01. So remember those 2 numbers in your head. We're going to go back to the whiteboard and write them down. So we need hydrogen, 1.01, carbon, 12.01. So let's write that down here in the blank spaces. Okay, so atomic mass of carbon, 12.01. Atomic mass of hydrogen, 1.01. Now, if you take a look at methane, we have 4 hydrogens in this compound, so we're going to multiply the value of 1.01 times 4. And we're going to do a total of these 2 values, which means we're going to add together the 12.01 plus the 1.01 times 4. So taking out your calculator, we are going to do a little bit of math here. And we're going to do 12.01 plus, I'll put everything in a bracket for hydrogen, 1.01 multiplied by 4, close bracket, and that equals 16.05 grams per mole. So I will write that down on my whiteboard to remember the total, 16.05 grams per mole for the molar mass of methane. So pretty straightforward. If you need to review molar mass, again, go back to your Google Classroom and do the example questions that I have posted online. We are going to move on now to take a look at some questions where we have the mass related to the number of moles and the molar mass specifically. And then we will look at a second question where we incorporate the ideas from the previous video with the Avogadro's constant and the number of particles in order to combine all of these ideas. Now, where we're looking at number of moles, there is a handy equation that you will need to know, where the mass is equal to the number of moles multiplied by the molar mass of a substance. M here is your mass, and mass is expressed in grams. Now, some questions, depending on how large the substance is, will give you that particular mass in kilograms. So remember to do unit conversions. 1 kilogram is equal to 1,000 grams. So don't get tripped up with your calculations. Likewise, if you have to go backwards and forwards, maybe the question at the end might tell you to express the answer in kilograms. Know how to convert between grams to kilograms, right? Either multiplying or dividing by 1,000. Again, number of moles is your moles here, or your N, expressed in mole. And the big M is your molar mass. Molar mass is expressed in grams per mole for the units. The molar mass will change every time depending on what substance is involved in the calculation, right? So let's look at example number 1. So here we have a lab technician, and this lab technician needs 2.0 moles of calcium nitrate to carry out a reaction. What mass of calcium nitrate does she require? So again, just like in the previous video, the way you're going to solve these questions is you're going to use the grasp or the grasp method. Okay? So with your grasp or your grasp method, right, remember you're going to write down what's given, required, your analysis, your solution, and then you can write a final statement. I know in the previous video we didn't actually write a therefore statement or anything like that, but if you want to be thorough, you can say therefore we have so-and-so mass of the sample or moles of the sample, etc. So let's move forward and solve the question. So here, we're going to first write down the information that's given. So we have information about the number of moles of the substance, but we're also told that this particular substance is calcium nitrate. So before we write down these number of moles, maybe as a little review, we should come up with our chemical formula of calcium nitrate. Remember, calcium on your periodic table is Ca2+. Nitrate is a polyatomic ion. Oops. And with your polyatomic ions, remember you can go back to your periodic table of ions. The little table on the top will show you that nitrate is NO3 minus, and you will cross your charges. So what you should end up with is Ca NO3 with a little 2 at the bottom. So this is your compound that you will be working with. And you'll need to know this in order to solve for your molar mass. So based on the information that we're given in the question, we know that we have number of moles of Ca NO32, which is 2.0. And we can also calculate for the molar mass of CaNO3 by using our periodic table. So in consulting with your periodic table of elements, you will notice that you can do that online. So we'll switch to our ptable.com. So you'll look up calcium. Calcium has an atomic mass of 40.01, nitrogen 14.01. You also have some oxygen in there, 15.99, or you can use 16. And then don't forget those subscripts, which you'll be multiplying the oxygens by. Okay, so let's switch back and I'll show you how it's done. So we're going to figure out the molar mass here for everything involved. So we only have one calcium. Nitrogens, now these are in the bracket. You're going to do 2 times 14.01 plus, you have a lot of oxygens here. You have 3 inside the bracket times a 2 on the outside. 3 times 2 is 6 times 15.99. That will give you your answer. So again, pull out your calculator and solve for your molar mass. So you will input into your calculator 40.01 plus 2 times 14.01, and then add 6 times 15.99. That equals 163.97. And taking a look, that's our molar mass in grams per mole. So these are the two things that are given to us in this question based on calcium nitrate. What's required? So what do we need to solve for? So it says, what mass is required? Well, we don't know the mass yet of the calcium nitrate, but also remember that we know about the Avogadro's constant. So maybe we should jot that down over on the side. We always know the Avogadro's constant. That could be useful later on. Okay, so keep that in mind. And it's some sort of particles per mole that are required. Now we have two equations that we can work with in terms of our analysis. Remember from the previous video, we have number of particles is equal to number of moles times the Avogadro's constant. And this time, if we're working with mass, number of moles and molar mass, we know that we can solve for the mass with the number of moles times the molar mass itself. Based on what's given to us here, we've got number of moles, we've got the molar mass, we're looking for the mass in the question, so we can just go through and solve using this equation. We don't even need the Avogadro's number here because we're not looking for any number of particles. So let's solve. So in terms of our solution, we're just going to look for the mass of the CaNO3 by plugging in the number of moles and multiplying by the molar mass. So we're just going to do a straightforward multiplication and solve accordingly. Again, what you're going to notice is certain units cancel out. So moles cancel out here, moles cancel out here, and you will be left with grams. I'll give you a moment to do the multiplication. I'll do this along with you. So what you will end up with is 2.0 times 163.97. So you end up with a value double your molar mass, which is 327.94 grams of calcium nitrate. Right? And if you wanted to write a final therefore statement, you could say, therefore, she needs, and how many significant figures do you need? Well, you only have the small significant figures here, 2.0, so you just need 2. So you could just round this to the nearest whole number, 330 grams if you like. But, so we could say, therefore, she needs 327.94 grams, or approximately 330 grams of calcium nitrate. right? Just so we're answering the question. So this is our final statement. So this is how we do the first question using the information here that was provided to us about the number of moles and the molar mass of the substance. In the next example, we have potash fertilizer contains a number of different potassium compounds, including KCl, potassium chloride. What mass of KCl contains 3.00 times 10 to the 25 formula units of KCl? Solid. The molar mass of KCl is 74.55 grams per mole. We're going to go about this question the exact same way as the previous one by using the GRASS method. So our first step is going to be noting down all of the given information. Oops. So let's zoom that back in. Now this question is going to incorporate the information from the previous video, as well as the new information we just discovered about the relationship between mass, number of moles, and molar mass. You're going to notice right off the bat that the molar mass is already given. We don't need to consult the periodic table. And we have some information here about formula units. So perhaps Avogadro's constant is going to be helpful, as number of moles are not specified. So let's start. Given information, we know, I just mentioned Avogadro's, so always note that down. If you don't know how to do anything else in the question, write this down. And the particles that are mentioned here in this question are formula units. So we're going to write down that we have these formula units per mole. We're also given the molar mass of KCl, which is 74.55 grams per mole. And we're told the number of particles of KCl, which is the capital N variable, of 3.00 times 10 to the 25 formula units. Now, what do we need? What is required? Well, we are asked to solve for the mass. Okay, so we don't know the mass of KCl. Remember that in terms of our analysis now, what equations are we going to be using? What equation has mass in it? Well, from the beginning of the video, I gave you the equation that mass is equal to number of moles times the molar mass. But if you take a look at this equation here, you have two unknowns. You don't know N, and you also don't know M. How could you solve for one of these unknowns? How could you find N? Well, you could solve for N based on the fact that you know that your number of particles is equal to N times Na, right? Or rather, rearrange, oops, to find your number of moles, right? Where N is going to be equal to your number of formula units divided by the Avogadro's constant. So there's going to be a step 1 and a step 2 to our solution. So we're going to need N first, and then we're going to need to find M. So it's going to be very important to do this part first. So this is how we're going to analyze the question. So let's solve. So step 1, we're going to solve for N of KCl. So how do we find N? Remember, you have your formula units. Plug that in. And we're going to divide by the Avogadro's constant, which are formula units per mole, and you will get a value. That will be only in moles. Then you will proceed to step 2. Step 2 will involve calculating the mass of KCl based off of whatever number of moles you have here, multiplying that by your molar mass of KCl. Remember that you do have that information. We have that given to us. It's 74.55 grams per mole. And you will get an answer when the moles cancel out in grams. So if we solve accordingly, let's see what we get. So the first step, we'll pull out our calculator. Remember that things in scientific notation, you can write them in brackets. So the first one, we're going to take 3.00 and raise that to the power of 25 and divide that by the Avogadro's number. And we get 49.833 and a bunch of decimal places. So I'm going to write down a few of those things. Oops. So I'm going to write 49.8338. 49.8338. Moles. My formula units cancel. But I don't want to round right away at the beginning. We always leave the rounding till the very end in terms of accuracy. And then I'm going to take that number of moles and I'm going to translate that into the second part of my solution and solve for my mass. So I'm going to multiply that value by 74.55, and that will give me the mass of the KCl, which turns out to be 3,715.116, 3715, 116, or roughly 3715.12 grams of KCl. Now, if I look back at all the units, so once I substituted everything in, if I look back at all my units here, if I notice at my scientific notation, if I take a look at my molar mass that was provided, it has 2 decimal places all the way through. So what I might want to do here is write down this final mass in grams in scientific notation so that I have the correct significant digits. So in the right significant digits, perhaps this should be 3.72 times 10 to the 3 grams of KCl. And that's how you solve the question.